The function junction, The function junction, yeah. Alright, day 2 of functions. So yesterday we talked about functions and how they relate to equations and such. So today what we're going to do is we're going to talk about some equations, just to review how to solve some equations and take a look at the difference between linear and nonlinear in an equation, as well as a little bit of storytelling. Okay. So the first thing we're going to do is we're going to look at some solving equations. And again, this should be review for most of you, and it's good to review. It's a good skill to have, is solving equations, especially as we move to next year into some form of algebra. So take a look at the first several. First problem, 2x minus 8 equals 20. First thing I want to do is draw a line down my equal sign. And again, what we're trying to do here is we're trying to solve for the variable. We're trying to solve for x. So I want to isolate x, get x by itself. So I'm going to get rid of anything that's attached to it. And usually I start from the outside, work in. So what's attached to it on the outside would be this minus 8. And how do you get rid of a minus 8? Well, you do the opposite of a minus 8, which is a plus 8. So I'm going to add 8. And I got to do it to both sides. Okay, that leaves me with 2x equals 28. And now I'm almost done here. I still have 2 attached to the x. And what's gluing 2 to the x? That is multiplication. And of course, what undoes multiplication is division. So divide by 2, x equals 14. Okay, so that's just kind of like a little warm-up as we move forward into some of these problems. So take a look at the next one. Here we have 2/3 x equals 20. Now there are several different ways you can tackle this problem. You can change it to a decimal. You could do the reciprocal of it. There's a couple different ways you can do this problem. If you have a way that's working for you, feel free to continue to do that way. What I like to do, and it kind of stays consistent with some of the other problems that have fractions, is I like to get rid of the fraction. And since there's only one fraction in this problem, I'm just going to multiply everything by the denominator. What number is in the denominator? 3 is in the denominator. So I'm going to multiply both sides by 3. So I'm going to multiply this side by 3 and this side by 3. When I undo that 3 on the bottom, they go away. Okay, so all that leaves me on the left side is a 2x equals 20 times 3 is 60. So you see I was just able to get rid of the fraction there by multiplying out the denominator. So now the last step, again I'm going to divide by the number on the top or the numerator, which is 2. So I'm going to divide both sides by 2, divide by 2, divide by 2. It's an awful division symbol, which leaves me x equals 30. Okay? So again, I just simply multiply out the denominator. So take a look at this next problem. We have 3/4 x plus 5 equals 20. A couple different ways to deal with this problem. You can multiply out the denominator right now and multiply everything by that denominator. You could subtract 5 from both sides and then multiply out the denominator. Whatever method you want to use, again, is fine with me as long as it's working out. So the first thing I'm going to do is multiply out the denominator. It's good practice. It also tells me I'm going to multiply everything by the denominator. So I'm going to multiply that times 4 and that times 4 and that times 4. So these 4's disappear. So all that leaves me is 3x plus 20. Oops, let me erase that. That's pretty bad. So 3x plus 20, because 4 times 5 is 20, and then 20 times 4 is 80. Okay. Then I got to get rid of this plus 20. What gets rid of a minus 20? Well, subtract 20. Subtract 20. That leaves me with 3x equals 60. And then last step, divide both sides by 3. X equals 20. Okay? So, or you could do it this way, and I'm just going to do this real quick. You don't have to write this down, but it's up to you guys. So, 3/4 x plus 5 equals 20. You could subtract both sides by 5 first. That's going to leave you 3/4 x equals 15. So then multiply out the denominator. So 4 times 15 is 60. So that's 3x equals 60. Again, same spot. Divide both sides by 3. x equals 20. So you get the same answer. I just did it in a different order. In this case, I subtracted my 5 from both sides. Here I got rid of my denominator first. Whatever way works for you is fine. Okay, take a look at the next one on the far left. Okay, again, so our ideal goal here is to get x by itself. So I got to get rid of anything attached to it. So what do I have attached to it? I have this minus 20. And again, what gets rid of a minus 20? Well, we are going to, let's try a different color. We are going to add 20 to both sides. Let me get my line drawn. Add 20 to the left side as well. 50 plus 20 is 70, equals 0.75x. Not just because it's a decimal, no need to freak out. You still treat it the same way. It's being attached to the variable with multiplication. What undoes multiplication? Division. So I'm going to divide by 0.75. Got to do it to the other side to keep things balanced. Okay, take your calculator. 70 divided by 0.75 gives me a decimal. Final answer here would be 93.3 repeating equals x. Okay. All right, now the next one we have a parentheses. So what you're going to do here is a little distribution. Remember way back when our Angry Birds distribution, you want to take 5 times 2x, 5 times 3. There's also another way to do this problem. If you have a way that works, that's fine. Continue to do it. So when I do my Angry Birds, 5 times 2x gives me 10x, plus 5 times 3 is 15. That equals 55. Okay, now it's a simple two-step solving equations problem. Subtract both sides by 15. Minus 15. That leaves me with 10x still on the left side. 55 minus 15 is 40. And again, what's gluing the 10 and the x together? That's multiplication. So divide both sides by 10. At this point, you can just do the division. X equals 4. 40 divided by 10 is 4. All right, now take a look at this next one. You can see it's a little bit more complicated. There's a lot more involved. Let me just get rid of some of this eraser stuff so you can kind of keep this a little bit organized. If you lost track of those problems, just hit rewind. You can check them out again. Okay, so first thing I want to do is draw my line down my middle here. So I got a lot going on here. I got 6x plus 14 minus 2x equals 1/2 times 8 plus 4. So there's a couple things I can do at once. First thing I want to do is I want to combine my like terms. I notice I've got 6x minus 2x. Well, they are similar. They're both apples. I can take care of that. Also, I have parentheses with just numbers on the inside, so maybe I just want to add those real quick to simplify that part of the problem. So 6x minus 2x is 4x. So 4x plus 14 is on the left equals 1/2 times 12. Because 8 plus 4 is 12. Okay, so I still have some cleaning up to do over here on the right side. I want to get rid of, I want to multiply 1/2 times 12. And 1/2 of 12 is 6. So 4x plus 14 equals 6. At this point, I'm going to subtract 14 from both sides. That's going to leave me 4x equals 6 minus 14 is negative 8. Now divide both sides by 4. Leaves you with x equals negative 2. Okay, so even though that problem looks complicated, there's really not that much complication involved because you know how to add and subtract like terms, and you know how to add numbers into parentheses, and you should by now know how to multiply a number by a fraction. Okay, a couple more together, and then we'll send you off on your own. Okay, here's a crazy fraction problem where we have more than one fraction with more than one type of denominator. So in this case, what you want to do here is you want to multiply both sides by the common denominator. So the common denominator in this problem would be 4. Okay, 2 can go into 4, so that works. So I'm now going to multiply everything in this problem by 4. So times 4, times 4, times 4, times 4. Okay, so when I do that, those 4's cancel. That just leaves me with 3. 2x. Now, this problem, 2 can go into 4 2 times, so that's going to leave me with 2x, so plus 2x. And 4 times 3 is 12, equals 40. Okay, real quick, let me just show you what's happening right here. So this would really be like the following. 4 times 1/2 x. Okay, so when you cancel across these guys out, 2 can go into 4 2 times. So that's why that leaves me with 2x there. Okay, combine my like terms on the left side. 3x plus 2x is 5x plus 12 equals 40. Subtract 12 from both sides. It leaves me with 5x equals 38. I'm sorry, 28. And x equals 5.6. Okay, so again, find the common denominator in both fractions. If you can't find the common denominator, just multiply the denominator by each other. That would be 8. And you would eventually get rid of the fractions, but they might be larger numbers. But if you can find the lowest common denominator, your life will be a little bit easier. Alright, and then finally the last problem here is when we have variables on both sides of the equation. You can see here we've got x's on the right, x's on the left. So what I like to do is I like to move the variable that has the lower value. So here I have 7x, here I have 2x. The lowered by x would be the 2x. So I'll get rid of that with the opposite. So it's a positive 2x. What's going to get rid of that is the negative 2x. So just subtract that to the other side. So that leaves me with 5x minus 12 equals 23. So at this point I got all my variables on one side, which is good to go. So then it's now a simple two-step algebraic equation. Add 12 to both sides. I'll do that quickly. Plus 12 plus 12. That leaves me with 5x equals 35. Then finally divide both sides by 5. X equals 7. Okay, so what I'd like you to do right now is go ahead and try the bottom 3 problems on your own. I'm going to give you a little hint on the last problem, but if you don't want the hint, go ahead and hit pause now. If not, if you want to listen to the hint, here is the hint. Spoiler alert. This fraction here, the lowest common denominator, the LCD, equals 6. So you multiply everything in this problem by 6. Okay? Go ahead and work on these problems. I'll have the answers shortly. Okay, so let's quickly go over these. So the first problem, what I did was I multiplied both sides by the denominator, which was 4, so that gave me 3x equals 48. Then simply divide both sides by 3 to get 16. Second one, distribute your 3. It gives me 12x plus 15. Subtract both sides by 15, then divide by 12 to get x equals 3. The last one, the lowest common denominator is 6. Half of 6 gives me 3x. 2/3 times 6 gives me 4x. 5 times 6 gives me 30. 10 times 6 is 60. Combine your like terms. 3x plus 4x is 7x. Plus 30 equals 60. Subtract both sides by 30. Then simply divide by 7 to get 4.3. Okay? So if you have any questions about these, feel free to ask your teacher. Again, this is a very important skill. Make sure you guys have that under control. All right, next page. Okay, so we want to identify if the following equations are linear or not. Now, just to remember, linear is a straight line. Something that's non-linear would be like the following. Okay, so it's not a straight line. You know, that's not a perfect straight line. Let's try that a little better. Okay, so let's see if these are perfectly straight lines. So real quick, I'm going to make XY tables, kind of like an input-output. And I'm just simply going to choose 1, 2, 3, 4, 5. So if x is 0, that would mean 3 times 0 is 0. If x is 1, 1 times 3 is 3. If x is 2, 3 times 2 is 6, 9, 12, 15. Okay, if I were to quickly draw this on the graph, so 0, 0, 1, 3, 2, 6, 3, 9, and you can see that in fact I do get a straight line. Okay, take a look at the next one, y equals x squared. So again, I'm going to draw an xy table. Use the same numbers, 0, 1, 2, 3, 4, 5. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. And 5 squared is 25. So let's quickly go ahead and graph these. So you see I just quickly drew that. You can sketch that if you want. But you can kind of tell that it is definitely not linear. It is not a straight line. You can see that right here. Here we have this curve. It starts here, then it curves, and now it gets very steep up the top. So this one is non-linear. So non-linear. And finally, y equals 1 over x. Again, let me draw a t-chart or an input-output. X, y. Again, 0, 1, 2, 3, 4. So 1 over 0, that's not going to work. So let's start with 1. 1 over 1 is 1. 1 over 2 is 1/2. Again, I'm just putting them right in here. So x is 3, that is 1/3. If x is 4, that is 1/4. And so on. If x is 5, that is 1/5. Okay, so let's try to draw this. Okay, now this one's a little bit more difficult to draw. You're just going to kind of have to trust me on this one. Here's how this graph would really look like. And you can definitely see that down here there's this gigantic curve, and that is non-linear. So non-linear. Take a look at the first graph. This one would be linear. So what do you notice about the three different equations? Linear, non-linear, non-linear. Now let me show you something else. What if we rewrote c using exponential forms? Does anybody remember how we can write 1 over x as an exponent? Well, if it's in the bottom of the denominator, that means it has a negative exponent. So I can rewrite this actually as y equals x to the negative 1. So now, let's take a look. What's the exponent above the x here? That is actually a 1. So do you see any clues that would tell you whether or not something is linear or not? I'll give you guys a couple seconds to think about that. Okay, well, if you said if an equation has an exponent above the variable that is greater or that is not 1, then it is non-linear. Okay, so here we have x squared. We get a non-linear graph. Here we have x equals negative 1. We get a non-linear graph. Here we have x has a positive exponent of 1. It is linear. So what you should be looking for is that variables just have exponents of 1. If they just have exponents of 1, you are going to get linear lines. So I would write here the following. So go ahead and write the following. Linear equations have exponent values of 1 above the variable. So if it's something other than 1, you know you're going to get a non-linear graph. So let's take a look at these examples. So for example, in number 1, here we have exponent of 1. Oops. Exponent of 1. This is linear. Exponent of 1. Exponent of 1. Linear. Now even though this equation looks funky, it's in standard form, it's not in y-intercept form. Doesn't matter. Look at the exponents. Exponents are both 1. Linear. Here's y equals 7. Now hopefully you know that this is a horizontal line. That is linear. Again, exponent of 1. 0.5x. Okay, even though it's a decimal, what are the exponent values? There's 1. There's 1. Linear. Okay, let's take a look at the second row. Now all of a sudden we have an exponent that is not 1. This is non-linear. you get a curved graph. So this one appears to be 1, but hopefully you remember your rules for exponents when multiplying. Well, this one actually simplifies to y equals 2 times 3 is 6. Now x times x, you got to add your exponents. So x to the second power. This is nonlinear because the sum of the exponents variables, the sum of the exponents is not 1 in this case. Okay, take a look at the next one. Here we have an exponent greater than 1, therefore this is nonlinear. Okay, this one I can rewrite to kind of show you what's happening here. This is y equals 3 times x to the negative first power, which is not a 1, so that's nonlinear. And then finally, here we have some distribution. Let's see if we can do our algebra together. This is going to be rewritten as y equals 3x times 4x is actually 12x squared plus 3x times 6, 24x. So what do you think, linear or nonlinear? Raise your hand if you think it's linear. Okay, now raise your hand if you think it's nonlinear. Okay, those people that raise their hand, they probably look funny right now raising their hand in class, but it is nonlinear. Okay? Alright. So go ahead, I'm going to hit pause, circle whether or not they're linear. I'm not going to hit pause, you're going to hit pause. Circle whether or not these next problems are linear or non-linear. So go ahead and hit pause right now. Okay, so here are the answers. Again, linear, all exponents are 1. Here we have a 2, nonlinear. Linear, that would really be 2x to the negative first, which is nonlinear. When you simplify this, this becomes 8x squared, nonlinear. Obviously nonlinear. Obviously nonlinear. This one is linear, all exponent values are 1. All exponent values are 1, linear. All right, finally, the last one. Take a look at a little bit of a story here. So here we have some graphs. Okay, we have a graph of distance from home over time. So distance from home over time, distance from home over time. Now, a couple things you need to figure out in these pictures, okay? What are we talking about with this? What does this mean? What does this mean when dealing with these graphs, and how do we figure out which graph goes with each story? So go ahead and read 8, 9, and 10. See if you can figure out which picture goes with which story. Okay? Go ahead and you can either draw lines or put the problem numbers inside the graphs to identify, but it's up to you. But go ahead and hit pause. Okay, so Arnold started from home and walked to a friend's house. He stayed with his friends for a while and then walked to another friend's house, which is further from home. Okay, so first thing we know is that he walked to his friend's house and then he stayed for a while. Okay, so that means his distance did not increase anymore. So his distance would be flat. That's what this means here. His distance from home has not changed. His distance from home did not change. So it's either going to be graph 3 or graph 1. What are some other clues here? Well, after he stayed at his friend's house, did he go back home? No. He continued to walk further from the house, so his distance got greater as he went on. So this one, his distance is actually decreasing from his home. So he's actually getting closer to home. Where here you can see this distance is getting farther. It's increasing. So in this case, this problem would be graph 3. Again, he walks to his buddy's house, stays there, then he walks further. Problem number 9 says Francisco started walking from home and then walked to the store. After shopping, he went back home. So in this problem, we can see that he went shopping for a while. So again, he stopped. His distance stopped. Even though time kept going on, his distance no longer increased or decreased. Well, again, you're looking at either graph 3 or graph 1. So why is it graph 1? Well, you can see he walked to the store here, shopped for a while, which meant his distance did not change. Then his distance to his house got smaller because he was getting closer to home. So eventually he got back home, which is why he returns back to the bottom of the y-axis here. So in this case, problem 9 would go with graph 1. And then finally, Celia walks to the library at a steady pace without stopping. Well, which graph doesn't show any stopping? That would be graph 2. And she's walking at a constant rate, so that would be graph 10. Okay? So what you guys should be doing now is you guys can start on your homework, which is the last page in this packet. You can use yesterday's packet and today's packet as kind of your study guide for your test on Thursday. And again, if you have any questions, feel free to see Mr. Comer or myself. Okay? Good luck and have fun.